Now, next one, we're going to talk about the dot products. The dot products of two vectors u, u1, u2, and vector v, v1, v2 is given by u1 times v1 plus u2 times v2, right? Note that the result should be a scalar. Alright, so simply add the product of two similar components, right? So I need to calculate the dot product of vector u and vector v, right? So I have 2 times 5 plus negative 2 times 8, right? So it could be 10 minus 16, it could be negative 6, right? Question B. The scalar number 2, I just bring it to the front, right? So I have 2 times u times v. But u times v equal negative 6 right here. So I have 2 times negative 6. It's going to be negative 12, right? Now question C. U squared, which means u times u, right? So it could be 2 times 2 plus negative 2 times negative 2, right? So it could be 4 plus 4, it's going to be 8, right? Now, question D, v squared is u times v, right? So this guy is the same thing as u times. Now, 5 times 5 is going to be 25. 8 times 8 is going to be 64, so you're going to add them up, right? So it's going to be vector u is 2 comma negative 2, right? Now 25 plus 64, now 25 plus 64 is going to be 89, right? 178 comma negative 178. So the answer for this one should be a vector, so be careful. Now we're going to talk about the orthogonal vectors. Two vectors u and v are called orthogonal, which means perpendicular, if the dot product equals 0, right? Perpendicular, normal, and orthogonal all mean the same thing. However, we usually say that vectors are orthogonal, lines are perpendicular, and lines and curves are normal. Alright? Now angle between two vectors. If theta is the angle between two non-zero vector u and v, right? So for example, I have vector u right here and vector v is right here. I need to calculate the angle between two vectors. Then cosine theta equals the dot product between two vectors divided by the product of two magnitudes of two vectors right here. Alright. Note that by crossing multiply, right? So if you cross multiply, you have the dot product equals the magnitudes of each vectors multiply each other, multiplied by cosine theta, which is another way of finding the dot product of two vectors. Alright, further emphasizing that the dot product of two vectors is a scalar. Alright, now example number 10. Given vector u right here, vector v right here, and vector w right here. Determine the angle between two vectors and if any of the vectors are orthogonal, right? So vector u and vector v first, we have cosine theta. The dot product between vector u and vector v, right? So 3 times 4 equals 12. Negative 1 times 3 equals negative 3, right? Divide by square root of this one square is going to be square root of 10, right? Times square root of 4 square equals 16, 3 square equals 9, it's going to be 25, right? Now 12 minus 3 is going to be 9 over 5 root 10, right? So I'm going to take inverse cosine both sides, right? So I have angle theta equals inverse cosine of 9 over 5 root 10, right? I'm going to bring up the calculator. Alright, so I'm going to press trig right here, inverse cosine, press the fraction right here, and then you input 9 over 5 root 10. Press enter. Convert this one to decimal. It's going to be 0.965, right? And of course, the unit is radian, right? If you want to convert this one to degree, you just multiply by 180 divided by pi, right? Now, question B. Use and W. So, cosine theta is the dot product between U and W right here. So 3 times 2 over 3, which means 2. Negative 1 times negative 8 over 9, which is plus 8 over 9. Divided by square root of 3 square plus 1 square is going to be 10, right? Times square root of 2 over 3 square is going to be 4 over 9, right? Negative 8 over 9 square is going to be plus 64 over 81, right? So I'm going to multiply the top and bottom by 9 for this guy right here, right? So I have 36 plus 64 is going to be 100 over 81, right? Now, if I'm going to simplify this one, it turns out to be 26 over 9 root 10 times square root of this one is going to be 10 over 9, right? Number 9 right here I can bring to the bottom, so that's why I get this one. Now 9 and 9 cancel out right here, right? So, and 26 divided by 2 equals 13, 10 divided by 2 equals 5, right? So the answer right here should be 13 over 5 root 10. Now I need to check inverse cosine of this one. So I'm going to press trig inverse cosine, press the fraction 13 over 5 root 10. Press enter. Alright, convert this one to decimal. Press menu, number, convert to decimal, press enter. The answer is 0.605 radian. Alright, now the last one, V and W. V right here and W is right here, right? So I have cosine theta equals dot product of V and W, right? So 4 times 2 over 3 is going to be 8 over 3. And 3 times negative 8 over 9 is going to be negative 8 over 3, right? Over the magnitude of this one is going to be square root of 4 square equals 16, 3 square equals 9, so it can be 25 times square root of 2 over 3 is going to be 4 over 9, and this one equals 64 over 81, so the answer we got right here, square root of 100 over 81, right? Now the top is 0, the bottom is 5 times 10 over 9. The answer is 0. Alright, so cosine theta equals 0. We're gonna take inverse cosine both sides, right? So theta equals inverse cosine of 0. This guy actually pi over 2, right? So the angle between two vectors is pi over 2, which is 90 degrees. So then vector V and vector W are orthogonal. Now we're going to talk about the domain of the vector value functions. The domain of a vector value function is the set of all t for which both component functions are defined. Alright, so we look at this one right here. We need to find the domain of each of this one, right? So we know that this one is radical, right? So we have the radical of 4 is going to be 2, right? Radical of 0 is going to be 0, right? But radical of negative 4 is undefined, right? So in order for this one to be defined, we need t plus 1 right here must be greater than or equal to 0, right? It must be these two guys right here, right? It cannot be negative, right? So you have t greater than or equal -1, right? Now this one right here we have log base a of b is defined when a greater than 0, a not equal to 1, b greater than 0, right? Now natural log of 4 minus t is the same thing as log base e of 4 minus t, right? So e is the Euler number, right? This one already greater than 0 and not equal to 1, right? So we need this one to be greater than 0, right? Look at this one right here, right? So we have 4 minus t greater than 0, then t less than 4, right? So the domain is -1, 2, 4, right? Let's move on to question B. We need to find the domain of this one. So we have e raised to the negative t is the same thing as 1 over e raised to the t. So t is any real numbers, right? So the domain for this one is all real numbers, right? Now we need to find the domain for this one right here. Now this one is the inverse function of sine function, right? So the input of this one right here is actually the output of this one, right? The output of this one, which means the range, right? So we know that the range of the sine function is from -1 to 1, right? So we need to find the domain of this one, which means -1 to 1, right? Domain of this one is the range of the sine function right here, right? Inverse sine of t has the domain -1 to 1, right? Now we need to combine this guy and this guy, so we need to use the intersection, right? Intersection of the real numbers and this interval right here, actually this interval, right? Now let's move on to example number 12. Sketch the vector value function of t equals t minus 5 I minus j, right? So observe that the one in front of I is the s value, so s equals t minus 5, right? And the one in front of j is the y value, so y equals -1, right? Now remember that y equals -1 is the horizontal line as -1, right? So it could be right here. T equals 0, s equals -5, right? Y is always the same thing, -1, right? So t equals 0, s equals -5, right? So have the first order pair right here, -5 and -1. So s equals -5, y equals -1, it's going to be right here. So the vector should be this one. Alright, next one, t equals 1, s equals -4, and y still -1, right? So it's going to be right here. The second vector, right? Now t equals 5 and then s equals 0, right? So it could be s equals 0 right here and y always -1, right? So it's going to be right here, right? And t equals 10 for example, and then s should be 5, y should be -1, right? So it's going to be right here. Now let's move on to example number 13. R of t equals 4 cosine t I minus 2 sin t j for t between 0 and 2 pi inclusive. Alright, So we know that S equals 4 cosine t, which is the I component, right? And Y equals negative 2 sine t, which is the J component, right? Now go ahead square both sides, so I have S squared equals 16 cosine square of t, right? Now you need to isolate cosine square of t, so it could be cosine square of t equal s square over 16, right? This one 17, you square both sides, so y square equals 4 sine square of t, right? So sine square of t equals y square over 4, right? Now I'm gonna add this guy up vertically, right? So I have s square over 16 plus y square over 4, right? Now sine square plus cosine square equals 1, right? Now this one actually the ellipse. Now observe that this one actually the horizontal ellipse with the equation s minus h square over a square plus y minus k square over b square equals 1, right? The center is h and k, right? Observe that the center in this situation is 0. So the ellipse has the center at the origin, right? Now in order to sketch the ellipse, we know that a square equals 16, right? So I'm going to take square root both sides, so a equals 4. So you just count from the origin to the left 4 units, right? Right here. And to the right 4 units. Now b square equals 4. So then when you take square root both sides, b equals 2. And then you need to count vertically 2 units from the origin. So it could be right here and right here. So the ellipse should be something like this. Now let's move on to example number 14, converting a rectangular equation to a vector value function. So we have the curve y equals s cubed minus 2s squared plus 3s minus 1. Now we just let s equals t, right? So we substitute t for s into this equation. So we have y equals t cubed minus 2t squared plus 3t minus 1, right? Then you have the vector value function r of t is, you just write this way. It could be s first, which means t, comma, and then y should be t cubed minus 2t squared plus 3t minus 1. Or you can write this vector value function in the I and j component, which is t times I, right? Plus t cubed minus 2t squared plus 3t minus 1 times j, right? Rules for vector value functions. When you add two vector value functions, basically you just add the I components and j components right here, right? Now scalar multiplication. When you multiply a number by a vector value functions, you just distribute the scalar like that, right? Now limit of the vector value function when t approaches a. You're gonna take limit of each I and j component, right? If the limit of either or both components of vector value functions fails to exist, then limit of the overall vector value functions fails to exist. Alright? Now continually, a vector value function R is continuous at t equals a if limit of the vector value function when t approaches a equals R of a. Alright? Now let's take a look at example number 15. Given the vector value function r1, r2, and h of t equals 1 over t. We need to calculate the difference between two vector value functions right here, right? So this guy is the same thing as t squared right here, subtract this guy right here, right? So we have t squared subtract 2t squared plus 3, right? And then I component plus the next one, negative 4t minus 1 subtract 2t right here, right? J component right here, right? Now we're going to simplify t squared minus 2t squared is going to be negative t squared. Negative 1 times 3 is going to be negative 3. I plus, now negative 1 times 40 equal negative 40 minus 2t is going to be negative 6t, right? Negative 1 times negative 1 equals 1, right? So plus 1. J component outside, right? Now question B, we need to take the magnitudes of these guys, right? So basically, you're going to take square root of this guy square plus this guy square. Alright, now I'm going to distribute this one. It's going to be negative, negative right here, I factor out. So I square is going to be positive, right? So I only have t square plus 3 altogether square. And then I need to use the complete square formula, a plus b square equals a square plus 2ab plus b square, right? So this guy turns out to be t power 4 plus 6t square plus 9, right? Now similarly, I'm going to use complete square formula for this one, right? So it turns out to be plus 36t square minus 12t plus 1, right? Don't forget the square root. Now I'm going to simplify this one, so it's going to be t power 4 plus 42t square minus 12t plus 10. This one is the final answer, right? Now question C. Now question C is going to be vector value function R1 of t. I just rewrite, right? So it could be t squared I minus 4t minus 1 j, right? Over. Now magnitude of this one is going to be square root of t squared altogether square plus negative 4t minus 1 altogether square, right? And then it's going to be t squared I minus 4t minus 1 j over square root of t power 4, right? Plus 16t squared minus 8t plus 1, right? I just use complete square formula right here, right? Alright, so vector R1 is right here, R2 is right here. So when you multiply them, you just multiply I components and then j component, right? So this guy turns out to be t squared times 2t squared plus 3, right? And negative 4t minus 1 times 2t. So I'm going to distribute this one. It could be 2t power 4 plus 3t squared minus 8t squared plus 2t. So I'm going to simplify. This could be 2t power 4 minus 5t squared plus 2t, right? Now h of t times r1 of t. h of t is right here, r1 of t is right here, right? So I just distribute this one to each of this one right here, right? So it's going to be 1 over t times t squared I minus 4 t minus 1 j, right? Now distribute this one is going to be ti minus 4t divided by t is going to be 4, right? 1 divided by t is going to be minus 1 over t j. Question F. H of t is 1 over t, right? Now r2t squared, which is r2t times r2t, right? Now r2t is 2t squared plus 3 and 2t right here, right? So it's going to be 2t squared plus 3 times 2t squared plus 3, right? Plus 2t times 2t, right? So I'm going to simplify this one. It's going to be 1 over t times 4t power 4 plus 2t squared times 3, it could be 6t squared, and this one is 6t squared, it could be 12t squared, right? And then 3 times 3 equals 9 plus 4t squared, right? T power 4 divided by t, it could be t power 3, right? So 4t cubed. Now 12 plus 4 equals 16, right? So plus 16. T squared divided by t, it could be t plus 9 over t. This one is the final answer. Now let's move on to example number 16. Limits of vector value functions. Find the following limits, right? So we need to find the limit of this one when t approaches 3, right? So we need to find the limit of each of these components, right? So we have limit of the first component right here, t when t approaches 3. It's going to be 3, right? Second limit of t squared minus 9 over t minus 3 when t approaches 3, right? So this one is indeterminate form, right? So we need to factor this one, right? So we have limit of t minus 3 times t plus 3 over t minus 3 when t approaches 3, right? So I'm going to simplify this guy and this guy, right? So this guy turns out to be limit of t plus 3 when t approaches 3 equals 6, right? So final answer is 3 right here should be 3i, right? And 6 right here should be plus 6j. This one is the final answer, right? Now, question B. We have limit of e to the negative t when t approaches 0, right? It's the same thing as limit of 1 over e to the t when t approaches 0, right? So this one approaches 1, right? Because when substitute 0 for t, it could be e to the 0 equals 1, right? Now, limit of sine t over 2t when t approaches 0. Now, we know that limit of sine u over u when u approaches 0 equals 1. This one is the formula you learn from unit 1, right? So we look at this one right here. We see that this is 2t, right? And this is 1t, right? So we need to remove 2 right here, right? So can I write this one as limit of 1/2 times sine t over t when t approaches 0, right? It's the same thing as 1/2 times limit sine t over t when t approaches 0, right? So I'm going to apply this formula. It's going to be 1/2 times 1 equals 1/2, right? So the final answer is, this one is the I component, right? So you have I plus 1/2 right here is the J component, right? This one is the final answer. We have limit of e to the negative t when t approaches infinity is going to be limit of 1 over e to the t when t approaches infinity, right? So the bottom approaches infinity, this one approaches 0, right? Now limit of 5t plus 1 over t when t approaches infinity, right? So I'm going to factor t out, so it could be t times 5 plus 1 over t, right? T and t cancel out, right? So when t approaches infinity, this one approaches 5, right? So finally, you have the answer 0i, which means 0, so you don't need to write it, right? 5j. So the answer is 5j. Now let's take a look at example number 17. Determine the intervals on which the vector value function is continuous. Alright, so we need to determine if this guy continuous and if this guy continuous, right? So we have 1 over t, right? Now this one is the rational function. This one continuous if t is not equal to 0, right? So you need to say that this one continuous except 0, right? And negative t is always continuous, right? Because this one is the linear function, right? So now you're going to combine this one right here. So finally, r of t is continuous on negative infinity to 0 union 0 to positive infinity, right? Now let's move on to question B. We need to find the domain of this one, right? So we have natural log of t minus 1 is continuous if t minus 1 greater than 0, right? So it could be t greater than 1, right? Now for the tangent function t. Now remember you learned from IB pre-calculus. The tangent function is continuous except n times pi over 2, where n is an odd integer. Now we need to combine this guy and this guy right here. Alright, observe that if n equals 1, you have pi over 2 is always greater than 1, right? If n equals negative 1, it's going to be less than 1, right? So if you draw the number line right here, you will see that 1 is here and n pi over 2 is somewhere right here if n greater than or equal to 1, right? So final answer must be the function r of t is continuous except t equals n pi over 2, where n is a positive integer. Alright, now let's move on to question C. You know that the cosine function always continuous, right? Remember, the cosine function is going to be like this, right? And the inverse of the cosine function is continuous on its domain, and domain of this one should be the range of the cosine function, right? So it could be negative 1 to 1. Now we're gonna combine this guy and this guy, which means we're gonna take the intersection, right? So R of t is continuous on -1 to 1, right? Now we're gonna move on to the next one, derivative rules for the vector value functions. First, we're going to talk about the scalar multiplication. So, k is the scalar multiplied by the vector value function. Then when you take the derivative of this one, you only take the derivative of the vector value function. So you need to keep the constant k, right? Now, addition and subtraction, you just split them up and you take the derivative of each, right? Now, multiplication by a function, right? So, we have the product rule, right? U times V you learn from unit 2, right? It could be U prime V plus V prime U. So you're gonna do exactly the same thing as you learned before, right? Now if you have two vector value functions, you apply exactly the same thing, right? Now let's move on to example number 18. Vector value functions and differentiation. Now given the function f of t equal this one, the vector value function u of t and vector value function v of t, find each of the following in two different ways. Now question A. We're going to use the product rule formula, right? U times v equals u prime v plus v prime u, right? So this guy turns out to be f prime of t times u of t plus u prime of t times f of t, right? F prime of t equals 2t plus 1 times u of t, which means 1 over t I minus j plus derivative of u of t is going to be -1 over t square, right? Derivative of this one right here. Derivative of this one equals 0, right? So minus 0j times u, which means times f of t, right? So t squared plus t. Now I'm gonna distribute this one, so this guy turns out to be 2t plus 1 times 1 over t is gonna be 2 plus 1 over t I. 2t plus 1 times j is gonna be minus 2t plus 1j. T squared times this one is going to be plus -1, right? And t times this one is going to be -1 over t, and then I, right? Now component j is right here is 0, so it's going to be 0, right? Now I'm going to combine this guy and this guy right here, right? So -1 add 2 is going to be 1. 1t add -1t is going to be 0, right? So I have 1i minus 2t plus 1j, right? Now I'm going to do the second way, which is I need to distribute this one first, right? So this one right here, and distribute is going to be t squared times 1 over t. It's going to be t, right? T times 1 over t is going to be 1. So I have t plus 1 I, right? Now t squared plus t times j is going to be itself, right? So it could be negative t squared plus t j, right? Now I'm going to take the derivative of this one. So derivative of t equals 1, derivative of 1 equals 0 I, right? Derivative of t squared is going to be 2t, derivative of t equals 1, right? J. Now I'm going to simplify, it's going to be 1i minus 2t plus 1j, right? The second method is faster than the first method, right? Now Second one, you do exactly same thing, right? So you have u times v prime is going to be u prime v plus v prime u, right? Now I need to take the derivative of u's first, right? So it's going to be right here. So it's going to be negative 1 over t squared I minus 0j, right? Times v times t squared I minus natural log of tj plus derivative of v is 2ti minus 1 over tj times u, which means 1 over ti minus j, right? Then I'm going to multiply this one out, right? So negative 1 over t squared times t squared is going to be negative 1. So I have negative 1 I. Negative 0 times this one is going to be 0, right? So this is going to be gone, right? Plus 2t times 1 over t is going to be 2, right? So 2i. Negative 1t times negative 1 is going to be plus 1 over tj, right? Now I'm going to combine this guy and this guy, so it could be 1i plus 1 over tj. This one is the final answer for the first case, right? Now the second case, I'm going to distribute first, right? So I have ut times vt, right? So this guy times this guy is going to be ti, right? This guy times this guy is going to be plus natural log of tj, right? Now I take the derivative of this one, so it's going to be 1i, right? Derivative of this one is going to be 1 over tj, right? This one is the final answer, right? So you see that the second way is faster, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.